So, if we check before, we have been actually talking about referring to the equation of a straight line, but never had calculations on that. So, in this class, we are going to focus on that aspect, the equation of a straight line, how to determine that, which after can be represented in any of these forms. They can ask you to find the equation of a straight line and have it in this form, have it in this form, have it in this form. All right? But if you are not told about the format now, you write in any way that you want, all right? But in most cases, we are going to focus on the what? Gradient intercept form y is equal to mx plus c. Unless you're told otherwise, then you can represent your equation in any one form that you want. The general form ax plus by is equal to c, or can be written in that manner, like I said. So let us see, okay, on that. To determine that equation, you can be given 2 points. These are now conditions that you might be given. You might be given 2 points, all right? So in this class, I'm going to explain everything. So it's going to be long. Given 1 point, can be given 1 point. Given 1 point and a gradient, as you can be asked to determine the equation of a straight line. You can be given gradient and y-intercept given the, actually, let us just say graphically, they can have this in form. They draw a line for you, all right? So let us just say from the graph, from the line that you are given. So basically on that one, you focus on the gradient and the y-intercept. That is the most important, of which you can also use points. It'll be in your hands. Use points, okay? Use 1 point and gradient. You can even go back here and apply those methods. So that is basically in terms of determining of our equation of a straight line, which I said, if you are not given or you are not told to express your answer in any way, you choose to express your answer in the form of y is equal to mx plus c, where y is the subject of the formula, but you can also write, guys, in any way that you understand best. The general form, if you understand that one, okay? So given 2 points, let us start with that one. When you are given what? 2 points. Given 2 points. We saw that when you are given 2 points, 3, 4, and another point is 1, 7, like this. We saw before that we can determine the gradient from there. Okay, remember that was our previous classes that we had. Given 1 point, given those 2 points, you are using the gradient, change in y over change in x, if you still remember. So what you can actually do is to determine the gradient from these points. And once you have that gradient, you use it now in determining the equation of the line, which can be expressed in different ways, that gradient, on how to calculate it. So first thing here, determine or calculate what? Calculate gradient. Okay. Then after that, use relevant, any relevant formula to determine the equation. To determine the equation. So that's it. Any relevant, so I'm going to explain different ways there. So let's say I have got my gradient, like for an example here, it's just going to call this x1, y1, x2, y2, and we determine our gradient, which is m. So remember, gradient is represented by the letter m, the change in y over the change in x. So that's it. Y2 is 7 minus y1, which is 4 over x2, 1 minus x1, which is 3. So that was going to give us 7 minus 4, which is 3 over what? 1 minus 3, that's minus 2. Then you take this one up. So it was simply going to be written as minus 3 over 2. Minus 3 over 2, okay? So this is our gradient. So that's the first thing that you do. You calculate the gradient. So we have our gradient minus 3 over 2 like this. All right. So to determine the equation from that gradient is the one that I'm gonna explain now. So let me just quickly verify this and see if we are on the same page. So that's negative 3 over 2 exactly. All right. So now to determine the equation from this gradient, that's where I'm saying use any relevant formula. There we can apply the formula which is written in this way, y minus, so I'm gonna have this, y minus y1 is equal to m into x minus x1. That's the formula that you can use. Some from this formula, instead they write it as y minus y1 over, they take this one, divide it, right? They divide by that x minus x1, and that's equal to what? M. When you divide by x minus x1, it is going to give you what? M. It is the same formula, just that written in different ways. So on this formula, I want you to understand this is the formula that you can use to determine your equation, and of which let us just apply these two, because so that we do not have confusion, guys. So I'm just going to apply this. You can write in this way or in this way. So here, the y and the x are the variables of our equation. This y and x, this y and this x, those are the variables that you are having on your equation. Y is equal to mx plus c, the letters that cannot be replaced, these ones, y and what? X, they are the variables. And m is what? Our gradient, this m here. As we can see, we have already calculated that m, this one, gradient, this one that you have calculated. So that is the one that you put there. So what about x1 and y1? This x1, y1 here is the point. It is representing a point, this x1, y1. That's the point. From the 2 points that you're given there, you can choose any one of your choice. You can use the first point, you can use the second point. So in actual sense here, it can be y minus y2. This one, x minus what? x2. So it can be written like that. So you choose any point. So that is from the point, the x1, y1, from the given point, from any given point. Any given point. So in this case, let's say we are using the first point, you're going to write x1, y1. The x value at that point and the y value at that point. So that is how you can simply determine the equation, just like that, guys. So let us use this, all right, the first one here, and apply it to determine the equation of this line which passes through these 2 points. So the line passes through the 2 points, 1, 7, and 3, 4. It's going to be something like this. The line is going to be something like this. 1, 7, and 3, 4. So that is something like this. The 2 points here, 3, 4, and this point 1, 7. They do lie on a line, on a straight line. So that is, you can use those 2 points to determine the equation. So like I said, you determine the gradient first, which is this one. Then you apply any relevant formula, which in this case, we are going to use any of these, these two formulas, which is simple, one formula, but written in different ways. So that is it. Y as a variable, like I said, X and Y, these ones are variables, guys. You cannot replace these. So they are variables, these ones. You cannot replace, just write them as they are. Our M is what? Our gradient, remember. So that's Y, our variable, minus Y1. So in this case, I'm going to use the first point. All right. So in this case, I'm going to use what? The first point. So you replace that first point. What is the value of Y1? The numerical value. Y1 is what? 4. So Y minus 4 is equal to what? You're substituting now. You substitute everything here that you have. M, the gradient, which we calculated, our M is what? Minus 3 over 2. So you substitute that is equal to minus 3 over 2, which is our M, the gradient that you calculated, into what? X. It's a variable, no substitute for that. So you just write it as X minus X1 from our point, from the given point, the first point that you chose, which is what? Which is 3. So if you chose the second point, you're going to have the same answer, right? I'm going to prove that, no problem. Let's work with the first point first and finish. All right, so from there, you simply have to evaluate so that you can have your answer in this form to make Y the subject of the formula. So that is what we need. We need this form. So evaluate from there, what you just need to evaluate to express that. So here you can expand the brackets, all right? Then later on, take the minus 4 to the other side. So that's Y minus 4 is equal to, let us expand the bracket here. So here we're going to remove bracket. Let's expand brackets. Expand brackets, all right? So that is minus 3 over 2 times x. This is going to give us minus 3 over 2x, all right? Then minus 3 over 2 times minus 3. Minus 3 over 2 times minus 3. Negative cancels. This is over 1. So 3 times 3, that is going to give us what? Positive 9. 2 times 1, that's a 2. So this is it. We are still on the evaluation. Let us make Y the subject of the formula. So Y is equal to, as we can see, it is affected by the negative 4. So what we simply need is to take that negative 4 to the other side of the equation there. So it was a negative. So here is going to what? It's going to add. So meaning to say that's minus 3 over 2. All right, minus 3 over 2x. Then here you simplify, you are adding 9 over 2 plus what? 4. So 4, that's a whole number. It's going to be same as what? 4 over 1. So to have it in the denominator of 2, you have to multiply this one by 2 by 2. So it's going to be 4 times 2, which is 8 over 2. So it's the same as 9 over 2 plus what? 8 over 2. So you can simply add the numerators. 9 plus 8, that's 17 over 2. The same denominator remains as it is. So that's going to be plus 17 over 2, all right? Of which you can just use your calculator. All right, 9 over 2 plus what? Plus 4. That is 17 over 2. So that is our equation at the end. As you can see, we have written this in the form Y is equal to mx plus what? Plus c. So that is from the format. This is about the format. So let's say they are the ones who expressed leave your answer in the form ax plus by is equal to c or plus c is equal to 0, whatever format that you're given. So in this form, you have to make sure that a, b, c, these constants, a, b, and c, these constants, they are what? Integers. They must be integers, these constants, all right? These constants must be integers. So it's another form. Remember, it's just a form. So let's say they said expressed like that. Let's see how it was going to look like. From here, it is y is equal to minus 3 over 2x plus 17 over 2. So to express in this form, we need integers. So we must clear these fractions. All right, so we must get rid of the fractions. Look for the what? LCM or the LCD, the lowest common denominator or multiple, which is 2. So you multiply by that throughout, multiply by the LCD. 2 times y, that's what? That's 2y is equal to, this was going to cancel. You have minus 3 times x, which is minus 3x. 2 and 2 cancels, you remain with what? Positive 17. All right, so remember, what we need here is to what? Express in that format ax plus by. So you have to start with ax, part of x first. So here we can take the x to the other side. This negative 3x is going to be what? Positive 3x. All right. Followed by what? Y plus y. That is the 2y that we see already on the left-hand side plus 2y. Then the constant, c is the constant. So that is the 17. We take it to the other side because all terms are on the what? Left-hand side. So you take the 17 to the other side, it's going to be negative 17. It changes the sign. So that's equal to 0. One side is equal to 0. So that is the same equation that we have here, that we had there. It is the same equation, this one, but only written in different forms. So that is why I was saying on the final answer, you must pay attention to the instruction. If there is an instruction that leave your answer in this form, leave your answer in that form, all right? Unless it is just determine the equation, then you can have it in any way that you want. So that's it. All right, let us move on. Like I said, I'm just gonna also prove on that point to say we can use any point on determining the equation of a straight line as we saw here. We can use any point. So meaning to say we could have used the second point. Let's see, using the second point, using the second what? The second point. So if we were to use the second point, our general form, I mean, this one that you're using to find your equation, y minus y1 is equal to, so it was going to be y2 because you're using the second point, x2, y2. So this is going to be y2 is equal to m, our gradient, into x minus x2. So remember, y and x are variables. These ones, we do not have a substitute for that. So that's y minus y2. That is the y value on the second point. This time we are focusing on the what? On the second point. The y value is what? 7. So y minus 7 is equal to m. Our gradient is not going to change. The one that you calculated before, minus 3 over what? Minus 3 over 2 into, all right, x is not going to change. X is a variable. There's no substitute for that, just like y here. So that's x minus what? x2. The x2 from our point, our x2 is what? Is 1. The value of x there is what? Is 1. All right, so here we just need to do this. All right, the x is not going to change. Minus our x2, which we said is what? Is 1. So that is what you're going to have. And from this, you can actually determine your equation. Simplify. You must obtain the same answer as this one. So the issue on the points is not important. So as long you have a single point that you can work with, you are still going to have what? The same answer. So let's prove that and see. So that's it. Y minus 7 is equal to, just like before, evaluate, expand brackets, times here, negative 3 over 2 times x, that's negative 3 over 2x, negative 3 over 2 times negative 1, that is negative to negative positive. So it's going to be a positive 3 over 2. All right, remember, we want to make y the subject of the formula. So you're going to take the negative 7 to the other side of the equation. It was a negative, so here it's going to add to change the sign. So that's it. So y is equal to minus 3 over 2x. Minus 3 over 2x. Then you simplify this. 3 over 2 plus what? 7. 3 over 2 plus 7. 7 is a whole number. So as a fraction here, we can have it as what? 7 over 1. So just in the denominator of 2, multiply by 2 by 2. So that's 14 over what? Over 2. So that you can simply add 3 plus 14, that's 17 over the same denominator 2. So that's 17 over 2 plus 17 over 2. So as we can see, it is the same answer as before, even if we are to work it from the second point. This is just a proof to say your equation here is correct. Even from the second point, we can see that we are still obtaining what? The same answer. So that is how you determine your equation of the straight line from that general formula, and you have your answer at the end depending with the instruction. All right. So like I said, this formula and this one are simply the same. If you're using this formula, all right, meaning to say you're going to apply this as, all right, so when I use this formula and use the first point, all right, so when I use that formula and focus on the what? On the first point, you must also obtain the same answer. These are just different ways of expressing our equation of what? A straight line. So this one, you're going to have y. Remember, these are variables. We do not have a substitute for that. So that's y minus y1, the value of y there, which is what? Which is 4. Over what? X minus x1, the value of x from the point which is 3. That is equal to the what? To the gradient m. The gradient that you calculated here, minus 3 over what? Minus 3 over 2. So that is it, just like that. You make y the subject of the formula, or depending on what you're given. So if you are using it like this now, in most cases, you find it easier for you to cross multiply. You will find it easier for you to cross multiply. So here you have to evaluate just like before. So you will find it easier to cross multiply, where 2 multiplies y minus what? Y minus 4. And this negative 3 multiplies everything here. X minus what? X minus 3. So that is it. Expand brackets, solve for y. 2 times y, that's 2y. 2 times negative 4, that's negative 8, is equal to negative 3 times x, negative 3x. Negative 3 times negative 3, that's a positive 9. If you were to make y the subject of the formula, definitely you're going to take the 8 to the other side of the equation. It was a negative, so on the other hand, it was going to be a positive. So that's minus 3x. 8 plus 9 plus 8, that's what? 17. Then make y the subject of the formula if you want to write your answer in the form of y is equal to what? Mx plus c. So that is, you simply have to make y the subject of the formula, divide each and every term by what? By 2. So that will be it. As we can see, same as before. You are obtaining the same answer as before, which is this one. So it depends with which side do you want to work it from. From here, y over y1, or you want to use this, y minus y1 is equal to m into x minus x1. I think I'm just going to use anyone, guys. You see, as time goes on. So that is it. You are given what? 2 points. So that is what I want you to do on this activity. I want you to find the equations of the lines which passes through these points, right? So this is an activity for all of you guys who are part of my classes on this platform. All right, so I want you to try use these points just like what I explained. Find the what? The equations. All right, find the equation of the line which passes through these points. All right, so let us do that. The comment section is there. Write your answers, each line, A, B, up to F. I'm going to mark you and see. Then we'll see what is going on. So that is an activity for each and one of you guys. Let us try and see if we are on the same page. Okay. So after this, we have another part, a straight line, right? I'm going to explain this. A straight line, all right, of gradient, this passes through this point. Write down A, the equation of the line. All right, so here, if you check, they gave us the gradient and they gave us a single point. So we go back here, guys, when I said, when you are to determine the equation of a straight line, one, you can be given what? 2 points, and you can be given 1 point and a gradient. So when you are given 1 point and a gradient, guys, the aspect or the issue is still the same, how to determine the equation of a straight line given what? Given 1 point and a gradient. So the aspect remains the same because the point is the one that you're going to apply it as your x1, y1. The gradient is your m. So if I have a point x1, y1, and that's still going to use the formula y minus what? y1 is equal to m into x minus x1. I can simply use that, guys, or y minus y1 in that other way. Still, we can apply the same concept as before, where x1, y1, this one is from what? From the point that you're given, and m remains the same, our gradient, where x and y are the variables. So that is how you can simply play around. So this one, they wanted you to use the same concept, guys. A straight line has got this gradient 4.5. All right, so we have our gradient 4.5, multiply, add, so that's 8 plus 1, 9/2. So our gradient is 9/2. Passes through the point what? You have a point, you are given the point. The point is what? 4 minus 3. Already they calculated, guys, the gradient for you. This is your point. They already calculated. You are supposed to have another point. Then from that point, you calculate the gradient, isn't it? Then you use one of the points. So here they calculated the gradient for you, and they chose the point for you to say, use that point. That is the only way that happened here. So that is it, guys. We can determine what? The equation. On A, write down the equation of the line on A. So that is the equation using any of those two ways. Y minus y1 is equal to m into x minus x1. We can have our equation. So y minus y1, the y value is what? Minus 3. All right, is equal to m, the gradient. Our gradient is what? 9/2. So it is equal to 9/2, our gradient, into what? X minus x1 from the point our x value is what? Is 4. Just like that. So this was going to give us the equation of what? Of that straight line, or you can use from this way, if you understand it much better that way. All right, so let us make y the subject of the formula. Minus, that's a plus. Y plus 3. All right, so here y plus 3 is equal to, expand brackets, multiply by what? 9/2. 9/2 times this. Negative 4/1. That's going to be negative 2. 9 times minus 2. That's what? Minus 18. So y is equal to 9/2x minus 18. We take the 3 to the other side. It's going to be what? A negative 3 there. So meaning to say y is equal to 9/2x minus 18 minus 3, that's what? Minus 21. So that is it, guys. 18, 3, that is what? 21. So this is negative 21. So we've got the equation of the line from that concept. All right, just like that. When you're given 1 point, that's how we play around. You already have the point, so you simply use your equation as before. Then B, the equation of a parallel line which passes through the point, this one. But they are what? Parallel. Guys, what is that we know about parallel lines? They have same gradient, isn't it? So here is just a repetition, guys. What is going to maintain here, what is going to maintain or what we are going to remain with from the first line that we were given, it is what? The gradient. Since the lines are what? Since the gradient, the lines are parallel. They have same gradient, like I said before. So you maintain the same gradient, but the point now where this other parallel lines is changed, it passes through the point what? It passes through the point 0 minus half. So that is 0 1 over 2, 0 half like this. So that's our point that we are given, of which this point is a special point, is the y-intercept, where x is 0. That is the y-intercept. So you can even just use that equation, y is equal to mx plus c, where m is what? The gradient. You put that gradient as it is 9 over 2x. C is the y-intercept, this one, where x is 0. Remember the y-intercept, guys, in the y-axis, where x is equal to what? Where x is equal to 0. So whenever you have a point like this, where x is 0, this other value is your y-intercept. The graph crosses, it crosses the y-axis at what? At 1 over 2. So you can simply write that 1 over 2 direct. This is our equation. Anyways, let's use this formula and see. Y minus y1, which is what? From our point, that's 1 over 2, is equal to m, our gradient, 9 over 2 into x minus x1, which is a 0. Okay, our x1 is 0. So that's it. Here, simplify. We can see that we can expand our brackets. So that was going to be equal to 9 over 2 times x. That's 9 over 2x. 9 over 2 times 0, that's what? That's a 0. There's nothing there. So y is equal to, we make y the subject, take the minus half to the other side. Definitely, it was going to add. So meaning to say, that's 9 over 2x. 0 plus 1 over 2, that's what? That's 1 over 2. Same as what we had before from the format that we could have actually taken advantage of, because it is what? One of the ways that you can actually work with in our syllabus. So it is actually acceptable if you can see that, just write direct, or you can use your formula as before. So that is how you play around with these questions. There we had a focus on 1 point and a gradient. Still, the same formula as before can be used. All right. Another aspect is where you are given the line drawn for you. If that line is drawn. So when the line is drawn, it is in your hands now. Are you going to use points, which are what? 2 points. From that line, you can figure out right here, the point is in the x-axis, where x is minus 7. So the point is minus 7, what? 0. And this point lies in the y-axis, where I can see that the y value is what? Minus 4. So the point is what? 0 minus 4. I have got 2 points. Just like before, you find the equation of what? The straight line. Remember, we are focusing on the equation of what? Of a straight line. So you determine your gradient, then you use n of the formulas, y minus y1 over x minus x1 is equal to gradient, which is our m, or you used y minus y1 is equal to m into x minus x1. It is in your hands, you see. So here, it is in your hands, but I do not want to apply that because we have already, guys, focused on that. I want us to use another way, which is the gradient intercept. The gradient intercept. If I can know the gradient of the line and the y-intercept where the line crosses or passes through the what? The y-axis. I can simply use this equation, this format, y is equal to mx plus what? C, where m, remember, is your gradient and the c is your y-intercept. So the intercept that you're talking about here is what? The y-intercept. That's another way that you can determine that you can have your equation at the end. So remember, let us focus on the first one. The gradient is the change in y over the change in x, which also you can use points. Those points that you had, you calculate gradient, or you can simply move change in y, change in x, where you produce L. All right, so the change in y going to the right angle, this is it, the change in y over what? The change in x. This is our change in x. So the change in y from -4 going up, we're going to the positive values. That's a positive 4. Change in x, we are going to the negative values from 0 to the negative. We're going to the negative, so that's -7. So our gradient change in y, that is what? 4, positive 4, over the change in x, -7. This is the same as what? -4 over 7. So we have the gradient. Therefore, we can have our equation. As the equation can be given in this form, simply substitute your gradient and the y-intercept. These two, you simply what? Substitute them from what you determined. So what you determined is what? -4 over 7, representing m, our gradient. So y is equal to -4 over 7x. All right, x is part of your formula. All right, plus the y-intercept, our C, the y-intercept, the graph crosses the y-axis here at what? At -4. The line crosses the y-axis as what? -4. So that's our y-intercept. So we've got the equation just like that, using this gradient intercept form. So y is equal to -4 over 7x. Okay, plus and minus is going to give us what? A negative. So that's it. This is the equation of the line that we had here. All right, so let's use that to find the equation of the line to the one that follows the second one. All right, so using this gradient intercept form. All right, sorry for that. So here, I'm going to use that on the second line. All right. So you're now on this line here. So on that line, the gradient change in y over what? Over the change in x. This is how we're going to move. So that's our change in y, our change in x. Going down, that's -4. Change in x, we're going to the positive. So this is +8. So our gradient was going to be change in y, -4 over what? +8, which is -1 over 2 if you reduce this. So that is it. Y is equal to mx plus c. Y is equal to m, our gradient, minus what? 1 over 2. That's our gradient. So that's -1 over 2x plus the y-intercept. This graph crosses the y-axis at what? At positive what? 4. So that is our y-intercept, +4. Just like that. So you see, guys, this is direct. So you've got your equation here. Y is equal to -1 over 2x plus what? Plus 4. So you could have used the points, and from those points, you're going to obtain the same answer. So your points will be what? This point where x is 0, that's 8 what? 8, 0. And here y is 4. So that's 0 what? 0, 4. You are still going to obtain the same answer from this aspect. All right, so I want you to use that just like before, where you've got what? 2 points. Determine the equation of the straight line. If you want to use that longer way, it is actually in your hands. You're going to have same answers. So for exam, you are not limited. All right, the last one here, the change in y over change in x, gradient, change in y, and change in x. We've got our L. All right, so this is our change in y, our change in x. So from 5 going down to the negative values, that's negative what? Negative 5. From 0 going this side to the negative, that's negative 6. So our gradient was going to be change in y, negative 5, over change in x, negative 6, which is what? 5 over 6. Therefore, our equation from y is equal to mx plus c is going to be written as y is equal to m, our gradient, 5 over 6x, plus c, our y-intercept, the graph that we have there crosses the y-axis at what? At positive 5. So that is your y-intercept plus what? Plus 5. Just like that, we have got the equation. So that is how you simply play around with these questions. Let us do revise as much as much as we can. Do revise, guys, so that you understand all the basics on your straight lines as they are to be used later on. These calculations, you're going to face them in exam. There is no question. Yes, we've got questions actually for paper 1, but mostly paper 2. You will find these calculations somehow where you do not expect. You find out they want you to find the equation of a straight line. You find out they want you to determine the gradient. So you see, all these basics, they are not in vain. They are very, very important in your examinations. So let us do revise in as much as we can. But for now, that is it, guys. Till we meet again.